Okay. There are all kinds of other things that we could do. We could have offset this plate so that it looks like it's sitting on top of the beam, but that is a bit technical. And to be honest, some of you guys don't really need to do that for your assignment, doing the offsets and all that. So don't worry about offsetting. Just the main thing is making sure that your beams are oriented correctly. Because if we were to do these I-beams and put it into a bridge structure, I-beams oriented like this aren't very strong with bending. They have to be oriented with the flanges perpendicular to the y-axis or in line with the x-axis. Flanges set on their side are not very useful in bending. So that's why it's very important for those guys, especially you guys doing bridges, that you orientate your I-beams correctly. Which one of you is doing bridges or bridges? I think let's see which projects here would be using I-beams. So if you're doing topic 2, not topic 3, not the wind turbine. If you're doing the 4-legged jack oil rig or working on the bridge, the overhead pedestrian bridge, you'll have to know how to do the I-beam orientation. Okay. Are any of you doing the liquid propane gas cylinder project? Any of you doing this topic? I think it's topic 5 actually. Are any of you doing this? Oh, okay. The carabiner? Oh, so, oh, okay. So Mariah, you guys doing this one, the chest press? Charles, you're doing the overhead bridge? What other ones? Who's doing the wind turbine? Anyone doing the wind turbine in this session? Okay, doing the topic 1 umbrella. The umbrella one should be pretty simple. I mean, you don't have to worry about all the curves. You just model the individual spokes and then draw those shell elements in between each spoke and then apply a pressure on the inside surface in the, say, in the negative y, in the positive y direction, just so it was pushing against the umbrella. So the umbrella one is very straightforward. Not too much to worry about there. Maybe just the modeling and setting up your different key points, that might be the difficulty. Liquid propane gas, these guys have a very specific modeling type that they can do. I can show them if they were here. Mariah, yours is, again, just modeling and setting out your key points and deciding what material properties you're going to use where. Applying the forces, yours would just be point forces for where the arms are pushing, or yeah, point forces, and then maybe a pressure on the backrest. Carabiner would be very straightforward. The wind turbine would be, you would set different sections. So what I mean by that is these guys would maybe do one beam this size, and then the next one a little bit smaller, and then the next one a little bit smaller, and smaller and smaller and smaller. So it looks something like a tapered shape, like the actual tower is. And then you would apply different pressures on each one of those members and apply a weight of your actual generator. And these guys, very similar to the bridge construction with different I-beams and just modeling that. So I can give some tips or advice as to how you would go about modeling these. But if you follow the procedure that I'm showing you right now in this lab, where you set different material properties, I think you all can get a good head start. And then next week, or maybe throughout the week, if you have questions, I know you have a short test this week, so you'll probably all be focusing on that right now. But if you have questions after that over the weekend, you can ask me and I can help you guys. So maybe if you could just spread the word to the other guys in taking MMCV312, just to let them know that I'll be able to help you guys once you guys are free. Right, so back to what we were talking about. Now I'm going to show you guys how to orientate these I-beams to be standing upright. So to do that, first we have to make sure that we clear the mesh. So we're going to go to mesh clear. We're going to clear lines, all the lines, and areas. Okay, we'll just remesh the whole thing. Multiplots. Right, back to where we started. Now, for I-beams, you have to create an orientation node. All right. Or if you go online and you search beam 189 orientation nodes, it'll show you exactly what you need to do. But basically, you have to create a node that is in the direction where you want your web to be oriented. What I mean by that is, let's just do a quick sketch. So what I mean by that is, right now, this is the Y and X axis, and our I-beam looks something like this, lying down on its side, and the flange, the web is in line with the X axis. We want to rotate this 90 degrees so that the web is in line with the Y axis. This is what we want. And to do that, we have to we've created the node here, which is the node of the two ends. So this is point 1, point 2. We've created the line that joins these two. We have to create a third node in the Y direction, or the direction that we want the flange to be facing, the web to be facing. So let's create a third node in the Y direction. So this is the X, this is the Y. We have to create a third node only in the Y direction so that we can orient our beams to rotate it to be in line with node 3. Okay. So back to our drawing, back to our model. Go to modeling. Let's go to move modify. Key points. Yeah, move. Oh, sorry, no. Let's go copy. Copy key points. And we select 1, 2, 3, and 4. Click OK. And we want to offset these in the Y direction. So let's set the Y direction to 1 meter. And we click OK. So now we have node 6, 7, 8, 9. And they're all offset from the ones that we have in there originally. So now when we go back to our meshing, mesh attributes, picked lines, we go 1, 2, 3, 4. Okay. Right, the material property was material property 1. The material section was black beams. Now when we say pick orientation nodes, we click yes. Okay. And now we have to pick our orientation nodes. So 1, 2, 3. Oh, sorry. Okay. We have to do these one by one, I think. So pick lines, go this line, apply. Yes. Let's go okay. Beam number 1. Okay. Again, this line. Let's go okay. Apply. Line, node 6. Apply. Let's pick the next line. Okay. Apply. Node 7. Apply. Last line. Okay. Okay. 0.6 and okay. So what we've done now is we've orientated all these beams and given them an orientation node. So now this line will be in line with 0.9, this line will be in line with 0.6, this line will be in line with 0.7, and this line will be in line with 0.8. All right, let's also mesh our lines that go up to this 0.1. These had material property 3. These were red beams. We don't need an orientation node for round hollow sections. Click OK. And the last one is our area. So let's pick all areas. This is material property 2, shell, section 2. We click OK. Now we go into the meshing tool. I think we've already set the sizes, so let's just mesh our area. You can see it's got a thickness. That's because our view setting is still on 3D display. Now also let's mesh our beams. So we set this to mesh, lines, mesh. Pick all. And now you can see that our I-beams are now oriented so that the web is in line with the y-axis. And this is what you guys will have to do for those who are designing a bridge. All right. Don't worry, I'm recording this session so you guys can watch back the recording and see how I did it. There's also lots of resources on YouTube, but just to make it a little bit easy for you guys to find it all, I'll just compile it all into these videos. All right. So our view is 3-dimensional. Let's just apply some boundary conditions and some random loads and see how this thing reacts. So right now it's a bit difficult to tell where are the key points and all because it's all showing 3-dimensional. So I'll just turn off my 3-dimensional settings for now. So style, size, shape, turn this off. Okay. Now let's go to loads, define loads. Let's go first, analysis type, new analysis, static analysis. Okay, set. Now define loads, apply, structural displacements, and on key points. So these 4 key points, I will fix them in all directions so they can't move. fully fixed. You guys who are doing the bridges, you would fully fix all of your supports. Because in reality, your supports wouldn't be a roller support or anything, it wouldn't be moving around, it'll just be fully fixed. And for the loads, I will apply one pressure on the plate and one point load at 0.1. Point load, 0.1. In the Y direction, let's say negative 50 kilonewtons, or let's say negative 10. Okay. I'll load downwards, and let's also apply a pressure on this shell. Areas, select this area. Okay. On the pressure value, let's make it 2 megapascals. So okay. Plot controls, and we can show all the boundary conditions applied. So we have our load, our restraints. I'm not sure what this pressure is doing, doesn't look quite right. Let's actually clear that, that doesn't look right. So delete structural pressure on areas. Now let's try and apply that pressure again. Maybe the load key was wrong. Maybe I need to change the load key to load key 2 maybe. Let's see what that does. No, the same thing. Delete that again. Let's just enter load key 1 and see what happens. All right. Now we've applied all our boundary conditions, everything. We can go about solving now. So let's go solution, solve, loading system, see if there are any errors. Check the model, produced 1 error. Okay, let's just say yes. Okay. So now it's solved, I think. We can go about pre-processing, post-processing, sorry. Let's just see the deformed shape. And this is sort of what we would be expecting. Yes. The plate is deformed at the bottom. The beams, they haven't really buckled that much. Let's show the deformed and undeformed. Okay, very little deformation in the beam members. I guess it's because the stress isn't that much. Yeah, and then you just go about doing the post-processing from this point on. But these are the basic steps that you'll be taking especially with regards to assigning material properties and sectional properties to each of the different members that you're using.